Remote access from and to your smart home is getting even better. Now we can use virtual private network services on our Apple TV and even set it up as an incoming server. I'll cut through the geek speak and explain VPNs without getting into obscure nerd stuff. Stick around and let me know if I succeed. Understanding the three kinds of VPNs and what they are for is the secret to using them effectively. VPNs connect things together. An outbound VPN is what many people use all the time. It can be hardware or software, free or paid, loaded on your computer or smartphone, or a self-contained box on your network, but it does one thing. An outbound VPN is like a secret tunnel that shields your internet traffic from prying eyes. When you connect to an outbound VPN, your data gets encrypted before reaching its destination. This is great for protecting your privacy when browsing the web, especially when using public Wi-Fi. Outbound VPNs protect you, the internet user, from unknown prying eyes such as hackers, the government, criminals, or when you're using the internet. The prototypical example is using Wi-Fi at a not-so-reputable coffee shop, fast food joint, or sleazy motel. With an outbound VPN, everything you do on the internet is shielded by data encryption as it passes all kinds of networks and gateways that you have no control over. How the VPN tunnel works, or even how it gets from point A to point B or point Z, doesn't really matter. It's a science fiction teleportation system for your data. An outbound VPN is like stepping into an MTA subway car in New York and then instantly stepping out from the metro in Paris. You have no idea how you got from New York to Paris, but you don't care as long as you have securely reached your desired destination. Why use an outbound VPN? In addition to encrypting your information, the VPN hides your physical location and doesn't keep track of the website or services you are using. If you use a VPN service, you'll want to choose a company and service that you trust because your privacy is ultimately in their hands not to log or save any of this information. VPNs let you bypass the restrictions that may be in place from your ISP or owner-operator of the Wi-Fi network you're using. I've been in public locations such as coffee shops, hospitals, or even shopping malls where they block or restrict the use of relatively benign websites such as YouTube and Dropbox because they don't want excessive bandwidth usage or fear legal issues from content on social media sites they don't control. The network owner might choose to actually block specific websites that you wish to use for your work or entertainment. As the owner of the network, it's their right, but damn frustrating when it happens to you. A VPN lets you slip past these restrictions, giving you the freedom to explore the web and internet without limitations. Ever encountered the dreaded "this content is not available in your country" message? A VPN lets you break down those barriers and access geo-restricted websites. Want to stream an anime show that's only available in Japan? No problem. Just connect to a Japanese server and voila, you're virtually in Tokyo. As an added benefit, some VPNs, especially the paid services, will load up on additional features, including ad blocking, pop-up window blocking, and antivirus scans. Nothing special you can't get elsewhere, but they're trying to provide the convenience of one-stop shopping to help justify their price. The inbound VPN is the next most common type. Just flip the VPN around and travel from the outside world back to our home or office. The use of inbound VPNs exploded during COVID, allowing all of us to commute to our office computers and systems in a fast, secure, and private way that didn't cause our IT departments to go insane. Inbound VPNs allow us to securely connect to our company or home servers from anywhere. It's like having a private highway to files, data, and devices that we are allowed to use without physically being there. Inbound VPNs are very useful for smart homes. Picture this. You're on vacation, but you forgot to turn off the lights at home. Or maybe you want to check if your robot vacuum is doing its job. An inbound VPN lets you control your smart home devices from anywhere. It's like having a virtual key to your front door. Inbound VPNs allow us to do all kinds of smart home things, from locking or unlocking doors, checking on security, or adjusting any devices or settings we want. But not all smart home systems have built-in remote access. And even those that do, they may have additional costs or high subscription fees to do it. Unlike these specialized connections, which might also require complex setup, a standard inbound VPN is versatile. It's not just for work or specific tasks. It's your all-in-one remote access solution. So these are big reasons to add a secure inbound VPN to your home network, adding flexible remote access and doing so without expensive subscriptions or fees. Now, the last kind of VPN is more specialized. Site-to-site VPNs combine both inbound and outbound VPN services to connect multiple physical locations together. When designed and installed properly, all the different locations, or sites as they are called, act as if they're part of one integrated network. Site-to-site VPNs are primarily used by large companies and businesses. A major retail chain, for example, will link all their stores together to headquarters, so any store will have instant access to real-time inventory levels everywhere. We take this for granted, but it's super useful to go to your local big box hardware store, and if that special tool or replacement part is not in stock, they can immediately tell you the closest store that has one. Could you use site-to-site VPNs for a fancy smart home system? Sure. If you have multiple homes, say a primary residence and perhaps a beach house and a ski cabin, you might find it cool to link everything into one overall system using a site-to-site VPN. Or maybe you have a large estate, ranch, or farm where you can't run Ethernet or even fiber optic lines directly between all the buildings. Then you might create a site-to-site VPN using microwave wireless transmission systems. With the more limited and specialized use, I won't be talking about site-to-site VPNs any further. So how do VPNs actually work? Well, I said I wouldn't get into all the technobabble and geek speak, but indulge me in providing a brief overview. Let's say the data you want to send over the internet was sent using a traditional letter and postal system. Your letter is placed inside an envelope that has both the sender, that's you, and the receiver written on the outside. Drop the letter in a mailbox or post office, and it gets delivered most of the time. Along the way, anyone could open the envelope and read your message. Or maybe they steal the mail bag from the mail truck or mail person, and the letter never gets delivered. With a VPN, two important things are done. First, a private tunnel from you to the destination is created. In data communications, the letter you wish to send is called the message or payload. The envelope you put it in is called the header, with associated address fields, which are the addresses of you and the destination. The truck, train, airplane, or person that moves the message from you to the destination is called the transport or network layer. So the message you put into your end of the tunnel travels all the way to the other end, avoiding the public roads, trucks, or vehicles without any chance of being diverted before it reaches its destination. In addition, before you place the letter in the envelope, it is scrambled or encrypted. The envelope can still be read, as it must be, to know the sender and receiver, but the contents of the envelope, the message itself, can only be unscrambled by the recipient. Time to add some magic. Let's explore the fascinating world of inbound VPNs with exit nodes. These VPNs combine the best of both worlds, offering features from standard inbound VPNs, along with the benefits of standard outbound VPNs. An inbound VPN with an exit node inherits all the features I mentioned earlier for standard inbound VPNs. It's your gateway to home sweet home, allowing remote access to your smart home devices and resources. Now, what if you could combine inbound and outbound services, having all the capabilities of each, and do it for free without buying new hardware and not paying any monthly fees? That's made possible by adding what's called an exit node to your VPN setup. It's actually exactly what it sounds like, a part of your home network, also known as a node, that lets incoming traffic go back out to the public internet. It's like having your own secret tunnel back out to the web. I know this is confusing, so let me explain a bit more. Normally, when you have an inbound VPN, you gain remote access to your home network, but your activity stops there. What if you want remote access to your home network, but then also want a safe and private way to continue using the internet? Say, for example, you're using the Wi-Fi at a coffee shop. checking on your smart home, but you want to do some research on Google or some shopping on Amazon, but are hesitant to do this at the coffee shop. With exit node capability, after you remotely connect back to your home network, you can pass through your home network and be routed back out to the public internet. So all your internet activity is going from the coffee shop to your home network, then out to the internet and back to you. Your internet activity never flows directly to the coffee shop's internet, so your internet activity is protected by the VPN with encryption, privacy, and security. All the servers and internet services you use will think you're at home and will not be aware of your actual destination. You could be on a safari in Africa while Amazon or Netflix still thinks you're home in Kalamazoo. Still confused? The magic here is that your home network is providing both the inbound and outbound VPN services and connecting them together. That allows remote inbound VPN connections to pass through the exit node and go back out to the internet through your smart home's outbound VPN. It's like a special U-turn road that only you know about and are allowed to use. Think of it as being your own full-service VPN provider. When you're away from home, you can still route your traffic through your home network to reach both your smart home and everywhere else on the internet. By using your exit node, you are bypassing public Wi-Fi risks and potential eavesdroppers. Your data remains encrypted and secure. Remember that blazing fast broadband or fiber internet you have at home? Well, your exit node taps into that same speed. It is reusing your own bandwidth efficiently. Hopefully, I haven't lost you with exit nodes, as I've saved the best for last. Inbound VPNs have one more trick up their sleeve. We can take an inbound VPN and turbocharge it even more by adding subnet routing. Ooh, yeah, those are two scary network geek words, subnet and routing. I'm trying to keep my promise of not subjecting you to geek speak and technobabble, so I won't be able to explain how this works, but without putting you to sleep, I can tell you why it is cool and how you can use it. To understand, I have to go back and explain a little detail I left out when using the standard inbound VPN. The way many inbound VPN systems, such as Tailscale, work, each device on your local network needs to also be running the Tailscale VPN software to enable communications. So every computer, smartphone, tablet, and laptop that you want to use as part of the VPN network will need to install the Tailscale software. This extra bit of complexity is for security and privacy. You control which devices are accessible remotely by choosing to install Tailscale or not. It's better than all or nothing by allowing you more granular control. When you install Tailscale, you are essentially creating a new local network. Unlike having multiple physical networks, which you can do with routers and switches, this new network is what software geeks call a software-defined network overlay, or SDN. Acronyms aside, this is really easy to do. You simply install Tailscale on each computer or device as desired. Tailscale software is free to download and use and is available for macOS, Windows, iOS, Android, and Linux. That covers all the popular computers, smart homes, and server devices. But it doesn't cover everything. And sometimes it isn't easy to install additional software on network devices that aren't just computers or phones. If you have network-attached storage, embedded Raspberry Pi servers, or proprietary hubs and bridges in your home network, it might be difficult or impossible to install Tailscale on them. But what if you still want to connect back to your home network using an inbound VPN for remote access and still be able to use those devices? That's where subnet routing comes to the rescue. It's a bit of networking trickery that lets one device on your network act as a gateway to all the other devices on your network that don't have Tailscale installed. So let's explore the fascinating world of inbound VPNs with subnet routing. These VPNs take remote access to a whole new level, allowing you to connect not just to your computers, but to all the devices on your home network. Whether you're managing your smart home gadgets or accessing files from your NAS drive, subnet routing has got you covered. Remember our trusty standard inbound VPN? Well, subnet routing builds on that foundation. You get all the perks we discussed earlier: remote access, convenience, and security. Picture this, you're on a business trip and you need to print a document from your home printer. With subnet routing, you can access not only your computers, but also your printer on your home network while you're away. It's not just about PCs and Macs. If it's on your home network, subnet routing lets you reach it. Here's the beauty. You don't have to install Tailscale on every device. Your VPN gateway handles the heavy lifting. Less hassle, more productivity. Subnet routing ensures that everyone can access shared resources seamlessly. Let's face it, configuring Linux-based VPNs can be intimidating. Subnet routing simplifies the process, especially for non-PC and non-Mac devices that may be running Linux or another proprietary operating system. Remember exit nodes that I mentioned earlier? Well, you can combine that too, so you can have your own virtual private network server running on your Apple TV with inbound VPN, outbound VPN, exit node, and subnet routing all available all the time. So there you have it, a VIP pass to your entire home network, accessible from anywhere. Whether you're adjusting your thermostat, streaming movies from your network-attached storage, subnet routing keeps you connected. Okay, time for a quick review. Outbound VPNs increase privacy and security and allow you to bypass ISP or Wi-Fi hotspot restrictions and geographic limitations. Inbound VPNs provide secure remote access from anywhere. Exit node allows inbound VPNs to also become outbound internet gateways. Subnet routing allows inbound VPNs to access devices that have proprietary operating systems or are too difficult to install VPN software. See, it's not really as complicated as you thought, right? Now it's time for the fun stuff. With tvOS version 17 or later from Apple, we can now use an Apple TV as an inbound VPN, outbound VPN, exit node, and subnet router using free Tailscale software, all at the same time.
An iPod, a phone, and an internet communicator. Are you getting it? These are not three separate devices. This is one device.
Like Steve Jobs said when introducing the original iPhone, are you getting it? All at the same time. So why use an Apple TV? Simple: cost, convenience, and power. For the most practical use of a VPN, the VPN server must be running 24 hours a day. An Apple TV is less expensive, uses very little electricity, is super easy to set up, and many people already own one. And bonus, Tailscale keeps running on Apple TV even when it goes to sleep. So when not active, Apple TV uses even less electricity, even less than a Raspberry Pi. So the Apple TV is the perfect device to use with Tailscale to set up a VPN. Here's how to install Tailscale on your Apple TV. For a standard installation, open tvOS on your Apple TV and click the App Store icon. Search for the Tailscale app and select Get. You may be prompted to enter your Apple ID password to confirm. Open the Tailscale app on tvOS. In the Welcome to Tailscale for tvOS page, select Install VPN Configuration, then select Allow. In the Tailscale app interface, click Connect. Scan the QR code to authorize your Apple TV to your Tailnet, which is what a Tailscale network is called. Alternatively, type the URL into your browser on your phone or computer to authorize and activate Tailnet. The Apple TV won't be accessible on the Tailnet until an administrator approves it from the web interface. For an intermediate installation, running also as an exit node, install Tailscale as described, then enable the option Run as Exit Node in the Tailscale app on your Apple TV. Now log into the Tailscale console on the web. Approve your Apple TV as an exit node. Optionally, disable the expiration of the certificate. I recommend doing this. Otherwise, periodically, your Apple TV will stop running and require you to manually log into the web and reauthorize the use of Tailnet. Advanced installation will add subnet routing. So using the Tailscale app on your Apple TV, enable subnet routing. Now this gets a little bit technical. You have to add a special number, which is the network address of your local network. Fortunately, there are two common settings you may have for your network. Your Wi-Fi network may be set to 192.168.1.1. If so, you'll enter the numbers 192.168.1.0 /24 as the route. If your home Wi-Fi network is 192.168.0.1, then as the subnet route, you'll enter 192.168.0.1 /24. I should be showing this information on the screen, and I'll also include it in the description below this video. If you have a custom network, you'll need to determine your subnet address for your network and enter that instead. That's beyond the scope of this video, mainly because I'm trying to avoid getting into all the lingo of IP addresses, subnet routes, class routing, etc. There are some good resources on the internet that will help you with this, or you can simply give up. After you've configured Tailscale on the Apple TV for subnet routing, log into Tailscale console on the web. Activate your Apple TV device if not already, and approve the subnet routes, either individually or all at once. And there you have it. Your Apple TV is now a powerful VPN hub ready to connect you to your home network wherever you roam. Interested in more examples of how to use Tailscale for smart home remote access? Watch this video next.